Okay, so we're going to do the last part of chapter 12.4, which is where we're completing the square to put these conics in the right form. You can look at this equation and go, well, it looks like it might be some type of conic, but maybe you don't know what type. Usually what I do when I look at this, I look at the largest degree term. So here we have the first term is an x squared, the second term is x to the first. So I want to look at the largest degree term. So that's going to be the x squared term, and y is to the highest power for this one. So I'm looking at those two terms. So I have 9x squared plus 4y squared. So there's a plus in between, so it's not a hyperbola. Both of them are to the second power, so it's not a parabola. A parabola would have one of them to the first power, one of them to the second power. So now you're down to either an ellipse or a circle. If their coefficients are different, which they are, this is definitely going to be an ellipse. So you want to get in the form of an ellipse. So like an ellipse is usually of this form, kind of like a x squared over, it might be a squared or b squared here. Those are kind of interchangeable. Plus y squared over b squared equals 1. And of course, this really might be not just x squared there. It might be x minus h squared. So x minus h squared. Same thing here for the y squared. That might be y minus k squared there. So those are squared. And again, we don't know if in the denominator if the a squared or b squared is in different spots, but that's the basic form we're trying to get this into. So we're going to try to put it into that form, basically. Okay, so let's try that. So first, let's kind of group the x's. So I'm going to write the steps over here. So you want to group the x's and y's together. So this is going to be 9x squared minus 36x plus blank plus, I guess it's just 4y squared. So we don't really have any other y terms to go with that. There's no constant. If there was a constant, I'd put it on the other side over there where the 0 is. You want to complete the square. So complete the square for both of those, which is going to involve a little bit of work here. We're going to have to take out the 9 here. You always want that leading coefficient to be 1. So I'm going to pull out a 9. So it's going to be 9 times x squared minus 4x plus blank plus, I'm just going to pull out the 4 there. So we just got y squared equals 0. I'm going to complete the square. So what that means is we're trying to figure out what value kind of goes in here. So this is going to be half of 4 is 2. 2 squared is 4. So we're going to put 4 there. Now to the other side, I have to be fair and add the same amount. But I effectively am adding 36 to the left-hand side. So I have to add 36 to the right because that 9 is being multiplied by everything in that parentheses. There's no completing the square over here for the y term. That's just the way it is there. So now let's finish this off. So this is going to be 9 times x minus 2 squared plus 4 times y squared, or y minus 0 squared, if that helps, equals 36. Now, to get this equation to equal 1 over here, on the right-hand side, we need to divide every term by 36. This actually works out really nicely. I really like this, the way this works. So the first term will be, when you simplify there, x minus 2 quantity squared over 4 plus y minus 0 squared, or just y squared over 9. It's a 9 there, equals 1. So we have our equation of our ellipse. And so you want to get it into the right form here. And this is definitely an ellipse. In fact, I would go this far. This is definitely a vertical ellipse because the larger value for A is underneath the y term, which is vertical. Let's try another one here. So again, the first thing you want to do is kind of identify what's the largest degree term of each one here. So we've got x squared. And for y, we have y to the first power. So that's the first power, that's the second power. So right away, you can go, okay, this isn't even Yeah, this is not even that tough for us, right? We know this is definitely an f of x parabola. We want to get it in the form of y equals a times x minus h squared plus k. So that's the form we're kind of getting for. If you want to solve this guy for y over here, get the x's on the other side, get the constant on the other side, etc. So it's going to take a little bit of work here. So for this one, you kind of want to get the x's to the other side. Let's do that first. So we've got 12y plus 9 equals negative x squared minus 6x. And I want to complete the square for this one, which means before I even start that, I really want to pull out the negative here. So x squared minus 6x plus blank. And you got to figure out what you can add to the right-hand side here to complete the square. Half of 6 is 3. 3 squared is 9. But effectively, I'm adding negative 9, so I'm going to subtract 9. Oh, that kind of works out nicely. I like it when a plan comes together here. It's very nice. So I get 12y equals negative, this would be x minus 3 squared. And then last step, you divide by 12. Divide by 12, you get y equals negative 1/12. That's your a, times x minus 3 squared. So this is an f of x parabola. The vertex would be at 3, 0, because this is like plus k here. This is like plus 0 for your k value. And so you've got your vertex you could graph or whatever you need to. The big thing is get in the right form and figure out what conic it is in this type of situation. So again, let's look at the two largest degree terms. We've got x squared and y squared. The coefficients are not the same, so immediately I'm thinking this is another ellipse. There's a plus in between, so to me this is definitely an ellipse. The coefficients don't match. If it matches, it would actually be a circle here. So you want to kind of group some of these terms together here. So I'm going to do 2x squared plus y squared minus 2y equals 1. I'm going to group the y's together and the x's together, complete the square. We've done stuff like this before, minus 2y plus blank equals 1. You're going to figure out what we want to add to each side here. So half of 2 is 1, 1 squared is 1, so I'm going to add 1 to both sides. So we get 2x squared plus y minus 1 squared equals 2. We really want that to be equal to 1, so we're going to divide by 2, divide by 2, divide by 2. You get, that cancels there, you get x squared, or x squared over 1 if you'd rather write it that way, plus y minus 1, that's a 1 there, squared over 2 equals 1. And that is definitely vertical. It's another vertical ellipse. So it's a vertical ellipse. I wasn't sure what kind at first, but now we know it's vertical. This one again, look at the largest degree terms. At x squared, we got y to the first power. That's definitely another f of x parabola here. So you want to, again, very similar to what we've done before. So negative 8y plus 9. This one might not work out as well. Let's see. Negative 4x squared plus 4x. And you want to pull out the GCF here. So that's negative 1 in this. Actually, you can pull out a negative 4 here. That's right. So x squared minus x plus blank. So now you got to figure out what you can add on that side to complete the square. Half of 1 is 1/2. 1/2 squared is 1/4. So I'm going to add 1/4. But I didn't effectively add 1/4. I did 1/4 times negative 4, which is subtracting 1. So I'm going to subtract 1 from that. So we get negative 8y plus 8 equals negative 4 times x minus 1/2 quantity squared. And we're going to, I guess we would subtract 8 then, so negative 8y equals negative 4 times x minus 1/2 squared minus 8. And now divide by negative 8 here. Divide this by negative 8. Divide this by negative 8. And you get, let's see, we get y, that's good, equals, this is positive 1/2 for your a value, x minus 1/2 quantity squared plus 1. So our vertex is at 1/2, comma 1 for my h and k there. And you can go on and graph the rest of it. What type of conic is this? So right away, hopefully you see it. The largest degree term is x squared minus y squared. So this is definitely going to be hyperbola. Finally, we get a hyperbola here to see what that looks like here. So I'm going to go ahead and distribute here and see what happens. Get all the x's on the same side. So I'm going to get x squared minus 10x minus y squared plus 10y. If you followed that, I didn't show all my work. I distributed and then I added. I subtracted 10x and I added 10y to both sides to move them to the other side. I'm going to group these terms together. I'm going to, let's see. If I group these, I'm going to have to change the sign. So if I put a minus sign in between, I'm okay with that, but I've got to change that sign to negative. So if I group those, so now let's try to complete the square here. So I get x squared minus 10x plus blank minus y squared minus 10y plus blank equals 1. And now we're going to complete the square here and see what happens. So half of 10 is 5, 5 squared is 25. So I'm going to add 25 to this side. Half of that is 5, 5 squared is 25. But this time I'm going to subtract 25 from both sides. So that's kind of interesting. So we get, this would be x minus 5 squared minus y minus 5 squared equals 1. Well, that looks like the equation of a hyperbola there. I just put those down there so you can see your a squared and b squared if you want to look at it that way. And so we know the center's at 5, 5, and you could then draw your hyperbola if you needed to. So that's the basic lesson there on how to figure out what type of conic it is that you see when you see it in that form.